Alright, get set, go.
Hey guys!
It's Miss McGee's room. Welcome to today's lesson.
Factoring.
Factoring. It's September 26th, 2017. Enjoy.
Is that supposed to be how I sound?
Thanks for enjoying.
Alright, here we go. Today's 26th.
Oh,
Alright.
that's right.
That's right. Alright, factoring. Here's what we're going to do first before we jump into factoring. How many of you have heard of
Greatest common multiple.
close, very close,
Denominator.
factor, aka
GCF.
GCF. How many of you have heard of that before? Good. Okay, tell me this. First of all, what is a factor? What does it mean to be a factor?
Something that goes into another number.
Something that goes into another number. Evenly, right?
Yes.
Common means something that's in common, something that's shared, right? And greatest is the biggest. So if I think about it, I'm looking for the biggest thing that something shares that goes into all of them evenly. Does that make sense? So if I give you just numbers, let's say I give you 2 and I give you 6. What is the GCF?
3.
2, okay? And if you're right in that if you divide them you get 3. But if you think about it, what are the factors? What are all the factors of 2?
1 and 2.
1 and 2. What are all the factors of 6? 1, 2,
And 3.
3, and 6. So because I'm looking, those are factors, so that takes care of the factor part here. I'm looking for the greatest, which is the biggest one that they share or they have in common, which would be 2.
Alright, what?
Can't see it? You know, Miss what? Right. You're so silly. Do we understand GCF with just numbers? Because we're fixing to throw some variables. Yeah, kind of like
I
that.
hated that.
We won't do factor trees though. Kenzie's doing that in her school. Let's say, y'all ready for this?
Why'd you do that?
Let's say I throw some variables in there, okay? Now, as you look at terms that look like this, I want you to think about when I find a GCF, I want the biggest thing that I can divide the coefficients by. What are coefficients?
The numbers.
Yeah, the numbers in front of the variable, right? I want the GCF of the numbers, and I also want to take out or take away or part of my GCF the most number of x's that I can from both also.
So take most of it. Okay.
So think about this like money. Sophie, you're 15 and you've got $2 in your pocket. Okay, Niaja, you're 10 and you've got $1 in your pocket. I want to take the most money I can for both of you, but I have to take the same amount from each of you. How much can I take away from each of you? $1 each, right? Even though you've got $2, since you've only got 1, and I have to take the same amount, I can only take 1. So my GCF here, what's 15 and 10? What's the GCF there? 5. And how many X's, how many dollars, what's the most I can take away? 1, and that's implied. Okay, so the GCF is 5X.
Oh my gosh.
Yeah, go over that one more time.
The one
again.
so like think of it as like if you know how x like being exponent is literally x times x. Like if you write it out.
Correct.
Cancel
Correct.
out what.
This one's got 2 X's because that's the same thing as x squared. This one's got 1. So remember, GCF is the biggest thing you can divide them by with no remainder.
So it goes like X.
So I look, okay, I've already determined that's 5, right? I'm not even going to look at those. Let's look at the x squared and the x. How many x's can I divide it by and it'll still go in evenly? just 1, right? Well, we're not taking it out quite yet. We're fixing to start taking it out. Right now, I just want you to be able to see it. Just see it. Look at another one. 27x to the 5th and 18x to the 9th. What is the GCF there? Greatest common factor. 3. Okay, so you're looking at the numbers in front, right? And you're telling me 3.
That's 9.
9. It is 9. Good job. 9, right? The biggest thing you can divide 27 and 18 by with no remainder. Does that make sense?
The X is 3.
The X, okay.
Wait, 5. Yeah, 5.
5.
Think of it as like writing out, like if you write out all of the X's that it has and then start canceling out however.
You
like,
take away the one that's got the least number of X's, that's the one you take. How about that? Okay.
Well, what if you,
One more. That's okay. I should 12x to the 4th and okay. What's the GCF?
6.
Close.
12.
Go a little bigger. 12. 12 x. Well, this one doesn't have 4. It's only got 3. So that's the most you could do. You can only do as much as the smallest x.
Okay, so, wait, that last one, you said, I can.
You with me? All right, we're not done with GCF by any stretch of the imagination yet.
So
So you take the smallest that
it's like you're taking something from both of those.
Which is exactly what we're fixing to do, and I'm going to show you. Yeah. You're taking something from both
So
of
it's
them.
like you was talking about with them two. It's like you're taking $1 from them.
Right.
And then you're just, so it's like you're stealing.
Oh, it's the Jasonisms again.
Come up with something like you did to Bo for the,
There's I can't.
And therefore, you should be able to win a staring contest, right?
yeah.
Because that's the logical argument that follows.
As you get older, I'm telling you, you can steal.
Okay, let me show you why we're doing this. Yeah.
So, like, I get that it's not easy.
Okay.
That's easy. So I think the smallest thing.
Yes. All right, let's say instead of a comma, I give you
instead of a what?
a comma. I give you this.
Oh, man.
I give you this expression, okay? And I tell you that I want you to rewrite this, taking the GCF out, okay? So I want you to think about this for just a minute. You before have done something, and y'all stay with me, that looks like,
Don't write that.
no, don't write this, just look at this. That looks like this, and I hope know that you could write that a different way by doing what? Distributing, right? And so when you distribute, you would multiply this through, correct? And you would get 5x plus 5. Well, we're doing the backwards of that right now. If I started with 5x plus 5, could you identify the GCF? 5, right? What's the GCF of 5x? You're looking at the green problem. Look at the pink problem on the side right now. What's the GCF of 5x and 5? 5. So then could you go backwards with distributing and instead of multiplying, divide each term by that and write it? So you put the GCF on the outside and you write what's left. Well, if you divide that by 5, and if you divide that by 5, you come back to what you started with, right? that's what we're going to do, is we're going to go backwards with it. So look at the green. Now think about it carefully.
So where did the
What is, yes. Where did the what come from? I'm fixing to show you. First, look at it and tell me, what is the GCF of all three of those terms?
2.
I heard 2. Everybody in agreement it's 2? Because I'm going to say there's something hooked to the 2.
2x.
2x. They all share at least 1x, right? That's the smallest exponent is 1x. I'm going to take that out.
So then it's going to be 2x squared plus
All right, look.
x.
Everybody agrees that's my GCF.
Yeah.
I'm going to put it on the outside.
In parentheses.
Now, because it's the backwards of distributing multiplies, yes? So then backwards distributing would divide.
So it'd be 1.
What's left? Look at the coefficients first. If you divide 2 by 2, it's 1. Now, Sophie started with $3 and I just took $1 from her. How many does she have left? 2. She still got $2 in her pocket. Right?
So basically you just divide everything by the greatest common.
Yes.
I thought it'd be 1x3.
Yeah.
You started with 3, but look, I took 1 away and put it on the outside.
Oh my. Okay.
Wait, why'd you?
Following.
Because that's the GCF. The GCF goes on the outside, and I have to divide the coefficients and take away what I took out on the exponent. Okay?
So she'll take an
But now
x from
how would
every
you
number.
get back to having 3?
Oh.
I'm not finished. I'm not finished. Look at the next one. Divide the 6 by the 2.
3x. 3x. Just 3x.
Yes?
Yeah.
Minus.
2. Yeah.
So now I'm not only finding the GCF, I'm putting it on the outside. Confused, Preston?
So.
On the coefficients or the exponents?
Alright.
Okay.
So would I add the exponents to the outside? Would that be the number from the outside?
The smallest.
I took an X from everything, right?
Right.
I took an X from everything.
You took 1x away from everybody. So that left you with 2, 1, and 0.
So, but the number on the outside is still just 2X.
It's just, yes, and the coefficients divide by that 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. 4 divided by 2 is 2. The point is, if you went back and distributed, would you get back to where you were starting? Yeah.
Will it always be like 3 numbers? Like 2?
What we'll be doing, yes.
It's a lot easier.
Look at this one.
Oh, wait.
Because that's what you put on the outside of parentheses. And then just put everything else in.
Let's look at one without a variable that's just got the coefficient and see if it makes more sense.
That's basically what I'm confused.
The variable? Okay.
Yeah, when I can't figure out, you said it's like you're dividing. But if you multiply 2x times 1x squared,
You get back the same original.
You get 2x to the
how do
third.
you get 3? Because you
Because
have
you
to
add.
add.
Add the exponents.
So
2 to 1.
The exponent is the only thing you're adding?
Yes.
But you multiply them.
Whenever you put that.
We'll get to more of that in chapter 2 when we do properties of exponents. Right now, I'm not going to have you take out any more than 1x. But I do want you to see that the GCF could be more than 1x.
I mean, if you just distribute that like it is, it's just going to be the same
What you
equation
started
that we
with.
started with.
Right.
Yeah. So when you check it, you can just do that.
Yes, yes. Okay. This is actually a form of factoring. This is just factoring out a GCF. Let's say so my question to you is, does it have a GCF?
Yes, it is. Well, if anything.
I heard 2 and then I heard no.
4.
4.
Yeah.
Does everybody agree that the GCF here is 4?
Yes.
Why is that the GCF? The biggest thing you can divide everything by and not have a remainder, yes?
Yes. So would
Okay.
you put 4?
Nobody's shutting down on me yet, right?
No.
Okay. Not yet. If I put a 4 on the outside, what is left on the inside? In other words, what would I have to multiply 4 by to make it back to 36x squared?
I don't know. I honestly don't know.
8.
4 times 6 is 24.
It's
4 times 7.
Look, y'all took out a 4. What do you have, if I was distributing this, what would need to be here to make it 36x squared?
9x squared.
9x squared.
I honestly.
Because remember, when you go back and distribute, you've got to have what you started with.
So, I thought it would be 9x with the 1 and 4x. Because you take
12
a
doesn't
x,
have an x.
Yeah, the 12 doesn't have an x.
so I don't take a variable.
Only if they all have it can you take it.
Plus 4x.
So wouldn't it be minus 3?
What would need to go here to get 16x back?
4x.
What was that?
Oh, that's Grandma again. Grandma likes to play pranks. And then minus 3. Does everyone see what we're... No, it's... Factoring is not solving. Factoring is rewriting. It's kind of like, okay, my daughter is in 5th grade, and she is... I think it was last year when she did it. And they started rewriting multiplication problems as addition problems to help them learn how to multiply. So in other words, 2 times 3, she would rewrite as 2 plus 2 plus 2. Right? You know what I'm saying? To teach them what multiplication was. Well, 2 times 3 and 2 plus 2 plus 2 are the same thing. It's just written a different way. These two things are the same thing. They're just written different ways. Does that make sense? Okay. Okay. All right. Most important thing here, can you take a GCF out if it's not a variable here like this, okay? And can you recognize what the GCFs are? Are you sure? Tell me if you can't. We good on that? A GCF takeout? Sure.
GCF takeout?
Let's do 18x squared minus 30x plus 12. Find the GCF and factor it out.
These are set up like the A.
And somebody said that second block, you're absolutely right. Somebody said this is confusing because it's like the A, the B, and the C in standard form. This whole chapter is about quadratics, and quadratics can always be written in standard form. Yeah? Got it? Good.
Oh, wait, we're doing
What if it doesn't have a GCF?
If it doesn't have a GCF, leave it, and we'll go on to the next step. But if it does have a GCF, you need to make sure you take it out. So just make sure you're looking. Yeah.
6 don't go at 30, does it?
Yeah.
Wow.
Got it?
Just kidding. I didn't say that.
Not
That
yet.
wasn't me. That was my evil twin. Her name is Lazisha. Lazisha. My evil twin.
Wow, some of you must not like your bonus for the...
Remember, I'm number 4.
I'm number 10. Wow.
All right. What's the GCF? 6. If I take that out, what's left?
3x squared minus 5x plus 2.
3x squared minus 5x.
Yes. Yes or no? Okay. Let's move on to the next topic.
Is it gonna be harder than this?
Okay.
She understands it.
Factoring is the process of taking. The factoring that we're doing anyway is going to take a quadratic, okay, that looks like this, okay, and it's going to make it look like this.
What?
Oh my gosh. That's
This is still the backwards of multiplying, okay? Because if I multiply these two out in parentheses here, I would get what I started with, okay? But when we factor, what we're going to get is two pieces that look like this. Now, understand this is just another way to write something, okay? If I told you that 2 times 3 was 6, and then I told you that 2 plus 2 plus 2 equals 6, it's the same thing, it's just different ways of writing it, right? One's is addition, one's is multiplication. This is his addition, this is his multiplication. Okay? Same thing, we're just writing it a different way. Alright. Don't shut down on me on this part either. This on the left is what you start with. Okay? This is what you end with, which is the factored form. Before I show you how to factor, we need to talk about what the signs are going to look like, okay? When I say signs, I'm talking about, here's the signs of what you start with. Here are the signs of what you end with, okay? And there's a pattern, and there's 4 scenarios, and the only thing that I can tell you is you are simply going to have to memorize them, okay? But I'm going to say it so many times that hopefully it will stick in your head. Okay? So I'm going to say your chart, what you start with on the left, factored form on the right, what you end with, okay? If you start, and this all is, it always goes by the second sign. This is your second sign, right? Right? First sign, second sign. If your second sign is a plus, okay, if your second sign is a plus, both signs are going to follow the first. Now think about that just a minute. It's a rule. If this, yes, if you start with the second sign being a plus, then both signs, once you factor it, are going to be whatever that first sign is. So here, the second sign is a plus, then they would both be plus here. If the second sign is plus but the first is minus, they're both going to be minus.
So the second sign is a plus, and the end part is whatever the
First sign was, right.
So
Remember when you're doing this, you're not going to be given this to start with. That's what you're going to be finding.
So what about when the second sign was a negative?
I'm fixing to show you that. So if the second sign is plus, follow the first. Oh, you can't see it off to the side. If the second sign is plus, follow the first. Okay? Second sign is plus, follow the first. Second sign is plus, follow the first. What happens if the second sign is plus? They follow the first. They're the same and they follow the first. Are y'all tracking with me? Okay. Now, Mackenzie asked a good question. What if the second sign is not a plus and it's a minus instead? And for that, I'm going to tell you that's the slightly stickier situation, in that it doesn't matter what the first sign is. These signs are going to be mixed, okay, which means 1 plus 1 minus. Okay, It will matter, and I'm going to show you how to tell our box. The method that I'm going to show you how to factor in, the box is going to tell you which one is which. Okay? All right. Second sign is plus. What are the signs going to look like? I'm going to check.
Can you scroll across that?
The first, whatever the first.
They both follow the first. If the second sign is minus, mixed signs. Okay? Mixed signs means I'm going to have to keep up with signs as I go. Okay? Are y'all tracking with me so far? If the second sign is plus, they both follow the first. If the second sign is minus, they're going to be mixed, and I'm going to really have to keep up with signs as I go.
And at the second one,
I'm going to start these going around the side. I did punch holes in them for you.
Oh, is that what you mean by the 4?
4 different scenarios. Right. 4 scenarios right there.
But technically they're like.
Technically it's 2. If the first is plus, if the second is plus, you follow the first. If the second is minus, they mix. All right, so coming to you is a sheet because I think we're finally ready to factor. Okay?
I can't write numbers.
I would not, if you want to jot some notes down on here, you're more than welcome to. I typed these out so that you wouldn't be frantically copying me as I did an example, but you could follow along, okay? If you look there, has everybody got one now?
no.
Who's got the extras? Okay.
Just kidding.
All right. There are some asterisks at the top of your paper, okay? Those are the first steps that you need to do. Are we shy one over there? We need one more. Got an extra?
So even the negative won't be negative?
Oh, we can pass it.
Oh.
If you're
Say that again, Jason.
So even the negative won't be negative?
Negative will be mixed signs. One positive, one negative. All right. You need a sheet? What's wrong? Y'all got sheets?
Yeah.
Okay. All right. The first asterisk. What's it say? Above common term, write GCF. Okay. You have to always check the problem you're doing for a GCF or else it's not going to factor right, okay? Common term, where it says common term, it says always check for a common term to factor out before beginning. Common term means GCF, okay?
You have to go.
No, sorry. All right. The second asterisk says check your signs, okay? And remember that if they're mixed signs or different signs, you need to keep up with them as you go through the box. Okay? Y'all ready for this?
No.
You ready or not? You will find that I think every teacher factors a different way. I'm a visual person. I've always been a visual person, and I guess that influences the methods I give you. This is a very visual way too. It's a technique that I learned at a conference that I was at years ago. And it seems to be the best method for students to understand the process. With that said, if you know another way, be my guest. Make sure it's a legitimate way. Okay. When I was in high school, they taught factoring as guess and check, and it stunk. It was terrible. You just had to keep putting numbers in these parentheses and multiplying out until you found what worked. Horrible. And so I hated factoring. All right. Here's what you're going to do. Yeah.
The other day I told my mom we were like just learned about like the parabolas and all that stuff.
Right.
She's like, I've never heard that word.
She never heard the word parabola?
Yes.
She just can't remember.
Because I was like asking her to help me with it, and she was like, I don't even know what that is.
Are we writing this down
All right.
on here?
No, I wouldn't write this down. This is on your sheet. Okay?
Oh, wow.
All right. First step. Do I have a GCF that I can take out? No, because 6, 7, and 2 don't have a common factor other than 1, right?
Well, 7 doesn't have a common factor.
One.
I mean, other than
One in itself.
Right, because it's prime. Okay. What are my signs going to look like once I get this factor?
Positive.
Both of them positive, right? And that's because if the second sign is plus, finish it, they follow the first. Okay. So when the second sign's plus, you don't have to keep up with signs as we go through this box. All right, stay with me. I'm going to walk you slowly. Set up a box. First term goes in the first square. The last term, guess what square it goes in? The last square. So remember, first term, first square, last term, last square. Okay? And you remember that? First and first, last and last. All right. Think about this like a puzzle as we go through this, okay? Multiply these two squares together. What do you get? Now here's the puzzle. And don't blurt it out when you get it. And if you're looking at your paper, then definitely don't blurt it out. I have to find two things that multiply to 12x squared, but when I add them together, they give me 7x. Okay? So as I try to find these, what I want to do is think about the factors. What can I multiply together to get 12? 3 and 4. What else? 1 and 12. What else? 6 and 2. And don't forget the x, because they've got to add to 7x but multiply to x squared. Does everybody agree that that's all the factors for 12? 12x squared. If I throw a plus sign in the middle of all three of those, which one will give me 7x?
3 and 4.
3 and 4.
So,
That solves the puzzle. Yeah.
Say again.
do I have to,
List them all? No.
okay, so like if I
You
was.
can find them without listing them all. I'm just showing you the process of getting started.
So when you mean like
So does it matter
If
which
it's
one the 3 and 4 goes in which box?
those second, you're gonna get.
Sure?
Yeah.
Okay. Preston, what were you going to ask? Did you get your question answered?
How did you get 3? I know how you got 3 and 4. Where you put 3.
There, I'm fixing to show you. I'm fixing to show you. What was your question? Yeah. All right.
Does it matter what?
No. Which box I go in? No. All right. I've got my two factors, okay? Everybody always wants to know. Some of you I was answering before you even got to ask math, because that's always the question. Does it matter which box which one goes in? And
Yes.
it does not. Okay? Because multiplication is commutative, all right? It's just going to change your order up of which piece is in front, and that doesn't matter, all right? So, it doesn't matter which box you put which one in. I don't know how I have it on your sheet.
The opposite.
Oh, good. This will show you then. All right.
Okay.
Now remember what I showed you in the beginning. We're trying to get two pieces multiplied together. The hard part's over, okay? This is the hardest part. Now remember, I've been talking a lot, and we've been answering questions, but really the only thing that we have done, first term, first box, last term, last box, and we multiplied them together and found the green numbers.
The middle number goes, like, on this one's picture, the middle number goes like after the.
It doesn't matter. The order doesn't matter. You could put the 4x at the bottom and the 3x at the top. It doesn't matter.
No, not the, it's the
She's
7.
talking about the 7x. They said at the top it says 3x plus 4x equals 7x.
They make it equal 7.
Oh no, that's when it's like 3 and 4, like adding them together.
That's where we're finding out which one of these adds up to 7x.
Start this tomorrow.
What?
Just,
We're almost done.
Okay,
regular TCL.
So does- how do I get to the F factor?
I'm fixing to show you. I swear I heard somebody knock at the door. Didn't you hear that? Okay, yes. Hard part's done. Now it's all downhill. Trust me when I tell you, finding the two factors, finding the missing two boxes, is the hardest part. I know y'all stayed with me a long time, and I appreciate it. I've been talking a long time, and I do apologize, but it's necessary today. All right, up and over. Here's what I do. I go up each column and across each row, finding the GCF of each of the two boxes I'm looking at, okay? So if I told you, and we did this at the very beginning, what's the GCF of 6x squared and 3x? What would you tell me?
3x.
3x, right?
C.
So then I look at the next column. Wait.
It says
They put it in different order. Don't look at the sheet right now. Watch mine. What's the GCF of 4x and 2?
2.
Now go across. And it doesn't matter if you go across this way or if you went across this way. It doesn't really matter. What's the GCF of 6x squared and 4x?
2x.
2x. Remember, if they got $1, you better take it. How about 3x and 2? 1. If there's ever anything that you can't divide, you can always do 1. Now we said in the beginning that the signs were going to be what? So this actually looks like
And you combine the two.
Wow.
this.
Okay.
and that's it?
And that's it.
And I think the clips in here, I got
I'm glad. Yes, Callie. Yeah.
Why did it look like
X.
Well, I hope that's, but if I didn't spend so much time focusing on GCFs, if I just assumed that you remember GCFs and I jumped in there, and we didn't spend so long talking about it, but it's gonna get,
Okay, now make that hard.
okay, it's gonna be harder when my signs are mixed. That's what I want to show you, okay?
Oh no. Because there's a 3 in front of the X.
Listen, Gail.
No, before. I know you're talking about.
Can we just?
Listen, I hope when you see it start to finish, you see it's not as bad. It's been long and it's been tough because I've spent so much time doing background stuff. But really the concept is this one slide right here. Huh? Yeah, that's on your sheet. I printed you. You still need me to leave it here a minute? Okay. I'll come back to it in just a second. All right, look at this one.
Alright, do you want us to write this down?
Yes.
Where? On that notebook paper?
I'm already on the back of it.
Take this number.
This is just an example, and this is an example that I don't have printed out for you, but that I do want you to see, okay? Because this is a different scenario. So remember, GCF, signs, box. Those are your 3 steps every single time. GCF, signs, box. GCF, signs, box. So GCF.
Signs box.
Right. Good job. Does it have a GCF? No. Done with that step. The signs, though. If the second sign is plus,
You follow the first.
you follow the first. If the second sign is minus, mixed signs. What are the signs going to look like here?
Next.
Mixed.
So,
Mixed signs, you have to keep up with them in the box.
that
Yes.
was my question. So when I put the -8 in the bottom,
Yes.
it's gotta be
Yeah,
negative.
it's got to be negative. You got to keep the signs. The only time you got to keep signs is when the signs are mixed.
So you just automatically go to the box then?
Yep, straight to the box. First term, last term. Okay? Multiply those two things together, and what do you get?
Negative 24x squared.
Now, think about this with me for a minute, and think this through. If I need 2 things that multiply to a negative number, what must be true?
Oh no, wait, ask that again.
If 2 things have to multiply to a negative number, what has to be true? One has to be negative and one has to be positive. Because otherwise, two positives make a positive, two negatives make a positive. Okay? So when I'm talking mixed signs, I'm talking these two things that I'm finding, one positive, one negative. Okay? So I need a positive and a negative that multiply to negative 24, but what do they add to? Look up. 10. Positive 10. All right, I heard 6 and 4. So let's try. I got 6. Well, list them out. Let's list them out and see. If I make the 6 negative and the 4 positive, what does that add to?
Well, that's not going to get it because it's a negative. So it could be negative 12 and positive 2. Or
Okay, so
positive 2 and positive 12 and negative 2.
there you go. Do y'all see what he did? As soon as we wrote those two down, because 6 plus 4 is 10. But as soon as we made one of them negative, we saw, but wait, that's not going to add to 10, right? Let's find a different factor. So Mackenzie said, how about 10 and 2? Well, if I make the 10 negative and keep the 2 positive, what does that add to?
8.
I meant 12, not 10, I'm sorry. Negative 10 though, right?
We even solved it. Wow.
I know. Oh, somebody grab that, y'all.
You changed that.
Positive 12.
I changed it to a 12 because it was,
Yeah, but then you
Oh my gosh, I did it again. Oh, I'm sorry. I'm sorry, video people.
It's not Monday anymore.
Oh my gosh. Okay. Now that adds to 10x, right? Remember I told you this is the hardest part? Finding these two numbers is the hardest part.
That's not even hard.
It's a puzzle. Think about it like a puzzle. It's got to multiply to something and add to something. Okay. 12x, negative 2x. It does not matter which box they go in.
Negative. Wait.
It's got to add to positive 10.
Oh, yep.
All right.
What would it be x squared?
No, because x times x is x squared and x plus x. Just adds. It doesn't. It's just an x. All of yours right now are just going to be x's in there.
So then you do.
All right. Now, let me tell you this. This is, yes, Maya. Shh, shh, shh. All right, guys. Shh, 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 shh. All right, do you see where I got the 24 from?
Yes.
Maya, you see that?
3 times.
Okay, I multiplied these two together to get the negative 24. So what I did was I just started listing things that multiplied to 24. 6 and 4, 12 and 2. And then I make one positive, one negative, and see which one adds to. Okay. Remember how I told you that the box would tell you which one was negative and which one was positive?
Yeah.
When you're finding a GCF, the only way to get a negative GCF is if both terms are negative. The only way to get a negative GCF is if both terms are negative. As you go up or over. Okay? So let's factor it. Go up the first column. What is the GCF? You're multiplying. Don't multiply. GCF. Remember, you got to remember what GCF is.
1x. Right? No, my bad. I was looking the other way.
3x.
3x. Don't divide the two. Remember, you're looking for the biggest thing. That's what you start getting everything discombobulated. You're looking for the biggest thing you can divide both of them by with no remainder. Okay? Here. This is what I was telling you. Do you see that they're both negative?
Yeah.
That means whatever the GCF is, it's going to be negative.
So this would be
Negative those.
2.
Wait, what about that?
Biggest thing you can divide 2 and 8 by no remainder.
Oh, see, I was going side to side, right?
Yes. Yep.
Yeah.
Well, they have to be, if they were going across, they would both have to be there to get a negative term. Like whenever I come across here, I'm going to have a positive and a negative. That's going to give me a positive GCF. All right, go across. GCF. Biggest thing you can divide them both by no remainder. 1 what?
Just kidding.
Just 1x.
GCF.
Is that here we write out 1x?
Yes,
So,
absolutely.
Next question here. When I put it into the, like when I put, alright, say I put 3x, whatever, quotation mark and whatever, quotation mark, does it matter where not like,
It matters which order these two are in. Like the -2's got to stay with the 3x and the 4's got to stay with the x. But if you write 3x minus 2, x plus 4, or if you write x plus 4, 3x minus 2, that doesn't matter. As long as the -2 stays with the 3x and the 4 stays with the
So
x.
then you just write it in the quotations?
Yep, 3x minus 2. Remember, mixed signs. But it told me which one was the minus and which one was the plus.
And that's literally it?
That's literally it.
This would be, why are we spending 4 days on this?
It's not as
I'm
hard.
sure there's.
This is not that hard.
There's more, obviously.
No, well, not a lot to
Y'all
factoring.
get this. I don't-
So why can't we do,